This is the full class video for Honors Algebra 1, section 9.5. This is a big video. It's definitely important. This chapter is full of important stuff. So learn all you can. Come to class with questions if you have them. Do your very best to pick up everything you can here on this video. Let's go ahead and read together number 1. It says a community center is building a patio area along two sides of its pool. You can see the high-tech picture there. The pool is rectangular with a width of 50 feet as shown and a length of 100 feet. You can see that there too. The patio area will have the same width on each side of the pool, so you can see that I've labeled those widths with an X, signifying that it's the same width, both parts. So part A says write a polynomial that represents the combined area of the pool and the patio area. Okay, so let's see what we can do here. A rectangle, I mean, really, if you take into account the sidewalk, the patio, and the pool, those two parts put together, you still have a rectangle. So what is the area formula for any rectangle? Well, it's length times width, or you could say base times height. So we got to figure out what the base is and what the height is. So my base is going to stretch from right here all the way over to here. And I know that the length of the pool, just that part, I know that that's 100 feet. And then I know that from here to here is X. So the length of the whole thing would be what? Sometimes folks will make a little mistake here and they'll say that it's 100 times X. But when you think about the way that lengths go together, if you're going to total up a length or total up multiple lengths, you actually add the lengths. So my base is going to be 100 plus X. Now based on that, I bet you can figure out the height, because the height is going to go from here to here. We know that the pool is 50 feet wide, so then plus a little bit more for the patio, the X there. So the height would be 50 plus X. Okay, so it did want a polynomial, and so we got to FOIL this out. So area is equal to, here's my firsts, there's my outers, there's the inners, and then of course the lasts. So my final answer would be 5,000 plus 150x plus x squared. Okay, so I've written the polynomial. We're good to go on A. Now part B is going to have us use this. So part B says if the combined area, which is what we just found, the combined area should be 8,400 feet, how wide should the patio area be? Well, doesn't this A stand for the combined area? So what do I do with this 8,400? I definitely don't plug it in for X, because X is just the width of the patio. I'm going to plug that 8,400 in for A. So it's going to be 8,400 is equal to 5,000 plus 150x plus x squared. Okay, remember our home base, our starting line for these is always going to be everything on one side equals 0. So I need to subtract 8,400. So it'll always be our starting line. So I get 0 equals, that's okay with you, I'm going to write in descending order of the variable. So it's going to be x squared plus 150x minus 3,400. This is kind of an interesting question because we actually have not dealt with anything like this before as far as this format. We've never dealt with having 3 terms. You know, in section 9.4 we had 2 terms a lot, but I don't think we ever had 3 terms. So this is going to require some different skills. So what we're going to do is we're going to come back to this at the very end after we have developed some of our skills. So let's not forget, the point of today is to come back here really and be able to figure out what X would be for this patio and pool combination. Okay, so we're going to build up our skills here first. We're going to practice factoring and solving polynomials of this form right here. ax squared plus bx plus c is equal to 0. So notice we do have the 3 terms. kind of like we had in the previous with the pool question. So we're going to talk about some of the techniques you could use here. I'm going to just primarily teach you one technique. I'll be really straightforward with you. There are multiple techniques. And if need be, I can bring those out. We can talk about those. But I found that the technique I'm going to show you today is the one that tends to stick with people the best. So let's start off looking at number 2. X squared minus x minus 56. We're supposed to create a multiplication problem out of this. And right now it's a subtraction problem. Let's do this. I'll tell you what. Let me reverse here real quick. Let me show you just something that maybe give us a little bit of momentum here. I'm sure you remember FOIL. We just worked on it earlier. If I just have a really simple FOIL, like say x plus 2, x plus 3, something like that. If I FOIL, I get x squared plus 3x plus 2x plus 6, right? Now I want you to notice something kind of interesting. You know, if I do continue to go here, of course I get x squared plus 5x plus 6. Please notice that 3 plus 2 gives me 5, and that's the middle term. But then 3 times 2 gives me 6, which gives me the last term. So what we're going to be doing here, I mean, notice how this and this are really similar in format. So what we're going to be doing here when we factor these trinomials, the 3 terms, this is almost going to be like unfoiling. Is really what we're doing here. We're going to unfoil something that has been foiled. So here's the pattern that we're going to do. We're going to kind of use that pattern I just talked about. And we're going to look at the last term. Here's what we're going to do with the last term. We are going to figure out which numbers multiply to be negative 56. So let's just take a quick survey of those numbers. What are some numbers that multiply to be negative 56? And here's an example. Negative 1 times 56, right? Could also be 1 times negative 56. I don't know, maybe you're shouting some other ones out. Maybe you're saying negative 4 times 14. Or how about 4 times negative 14? I don't know what you're saying. There's more. I mean, there's negative 2 times 28. And there's 2 times negative 28. There's even more, right? These might be the ones you've been saying. Negative 7 times 8 and 7 times negative 8. So the question is, how do we pick the numbers that we want? Well, we're going to follow the same pattern we do with FOIL. What we're going to do, we know that all these numbers multiply to be negative 56. What we're going to try to figure out is which of these numbers which of these numbers adds to be the b, the middle number there, the middle coefficient. Well, essentially what we're doing here is we're trying to figure out which numbers multiply to be c and add to be b. Which numbers multiply to be c and add up to be b. So here we go. Negative 1 plus 56 is 55. So that's not negative 1, right? And so that's not going to work. 1 plus negative 56 is negative 55. At this point, we can see that that's not going to work either. You start to look through this list, and you're like, well, this is going to add up to be 10. That doesn't match. This is going to add up to be negative 10. That doesn't match. Well, maybe we should skip to the end. How about negative 7 plus 8? That comes out to be 1. Well, gosh, that's really close because we were looking for negative 1. It's close, but it's not right. You look at the last one, 7 plus negative 8 is negative 1. So that means the 7 and the negative 8 are our factors. So I'm simply going to rewrite this as x plus 7, x minus 8. Now, how could you check this if you were unsure? Of course, you could just FOIL it back out. You should end up with what you started with. At this point, you have everything you need to do quite a few of these problems coming up. So if you want to, pause the video and you can try all 3 of these and then try to, play the video and try to see how you did, see if it's working out. So here we go. Here's number 3. I'm going to look for the factors of 48. And by the way, you'll get really fast at these. You'll figure out really quickly which types of numbers do and which numbers don't work. So factors of 48, well, I know, for example, 2 times 24. Well, 2 times 4 adds up to be 26. So that's not going to work. I could try this, right? Negative 2 times negative 24, because those two numbers multiply to be 48. But when I add those, I get negative 26. So both of these are out. You could try 1 times 48. But you get 49 there. So I don't think negative 1 times negative 48 is going to work either. What are your thoughts? I'm hoping that you're thinking 6 times 8. Because 6 times 8 is 48. And 6 plus 8 gives us 14. And that's what we were looking for. We were looking for a 14 from that middle term. So when we try to unfoil this, we're going to get m plus 6 times m plus 8. Again, you should be able to get really fast at this. Given enough time and practice, you should be good. Okay, taking a look at 4. Descending order, do you see why that's important now? I mean, if everything's in descending order, we just follow a nice orderly system, and these should start to get pretty easy for you. Okay, so C is negative, and so all of our factors here have to be opposites. So maybe I try negative 2 times 12. Well, that is negative 24, but when you add those up, you get 10. And we're looking for a 2 when we add those up. So that's not going to work. Well, maybe I could do 2 times negative 12. But when I add those up, I get negative 10. So that doesn't work either. Remember, I'm looking for a 2. Did you figure it out? Are you getting faster? I hope you are. Maybe we try negative 6 times 4. Because negative 6 times 4 is negative 24. But when you add those up, you get negative 2. And negative 2, obviously it's close. It's not right. I think we were kind of circling in on this, right? It's going to be 6 times negative 4. Because 6 times negative 4 is negative 24. When you add them up, you get 2. And that matches the 2 right there. So our factoring would be x plus 6, x minus 4. All right. I hope that you're pausing the video and trying. Here's our last factoring. Okay, so 45. Not very many numbers multiplied to be 45. I mean, there's 15 times 3. When you add those up, you get 18. We have kind of an interesting issue here because obviously 18 is kind of close to 14, but this is not 14. This is negative 14. So gosh, the only way that you're going to get a negative number there is if you add up two negatives. And so maybe I should try negative 15 times negative 3. Because that does multiply to be 45. When I add those up, I get negative 18. So neither one of these work. Well, how about 5 times 9? Because 5 times 9 is definitely 45. You add those up, though, you get 14. And now we're really close, though, right? Because 14, negative 14, we're only off by a sign. So maybe we should try negative 5 times negative 9. Negative 5 times negative 9 does multiply to be 45, and it adds to be negative 14. And that's exactly what we were looking for. So our factoring would be w minus 5, w minus 9. Hopefully you're picking up on that. Hopefully you're good at your multiplication tables. That makes a big difference. Okay, number 6. A couple here involving solving. So in number 6, we've got everything on one side equals 0. Of course, that's exactly what we want. But we want the polynomial, we want it to be in factored form because we want to use the zero product property, ZPP. So the zero product property means you have to have a product. And so the way that you get a product from something that's not a product is to factor. So let's factor. Let's see what we can do here. What numbers multiply to be negative 60? Well, let's see here. There's negative 2 times 30. Let's just do some mental math. That adds up to be 28, so that's not right. And of course, 2 times negative 30 is not going to work either. Let's see, there's 5 times 12. So 5, we should make one of these negative, I guess. Negative 5 times 12 is negative 60, but they add up to be 7. So maybe it should be 5 times negative 12. because that adds up to, oh gosh, that adds up to be -7. We're looking for -11, of course. So far, no luck. Did you figure it out? Have you thought of it yet? This is where knowing your multiplication tables does make a difference. What if we tried 15 times -4? Check it out. 15 times -4 is -60. And when you add those, you get 11. Yeah, we're off by a sign. So if I just make it -15 times +4, still the product is still -60, but the sum is -11. So here's how this looks. N minus 15 times n plus 4 is equal to 0. I come up here and I use the zero product property. I say that n minus 15 equals 0, n plus 4 equals 0, and then I solve. N is equal to 15, n is equal to -4. All right, if you haven't already tried it, try number 7 on your own. Pause the video, and I'll catch up. All right, so number 7, once again, we've got a trinomial equals 0. And the problem with that is we're going to use the zero product property, which we need to. We need to have a product on the left side, not a polynomial, not a 3-termed expression. So I need to factor. The way that you go from polynomial to a product is to factor. So let's figure this out. What numbers multiply to be 72? Well, let's see here. There's 36 times 2. But those add up to be 38. So that's not going to work. Let's see here. Gosh, I'm trying to think about it. I guess 24 times 3. Yeah, 24 times 3, but gosh, those are going to add up to be 27. We're looking for 17. Man, I don't know. Have you figured it out yet? I hope you have. Of course, it's 8 times 9, right? 8 times 9 is 72. 8 plus 9 is 17. So here's how this works. You would say m plus 8 times m plus 9 equals 0. Then we use the zero product property. We get m is equal to -8. M is equal to -9. Okay, let me just do a little bit of explaining on the instructions here for numbers 8 and 9. The instructions say find the zeros of the polynomial. What that means is set the polynomial equal to 0. It's just a little bit of terminology. It's used in your book a little bit. I want to make sure you understand what it means. So here's all it really means. 0 equals x squared plus 16x plus 28. It has meaning on a graph. It has meaning for applications, but right now we're just looking at your skills. So make sure you understand 0 of the polynomial means set the polynomial equal to 0. Okay, once again, we've got everything on one side equals 0, so we want to use the zero product property, but we don't have a product. So how do you create a product from a polynomial? You factor. So we're going to look at the factors of 28, just like we've been doing. We're going to figure out which numbers multiply to be 28 and add up to be 16. So right away I think of 4 times 7, because 4 times 7 is 28, but 4 plus 7 is 11. So that's not going to work. What else multiplies to be 28? There's not really that many numbers. There's 1 times 28, but those add up to be 29, so now it's too big. So we need to find something kind of in between. How about 2 times 14? Did you think of that? Again, this is where multiplication skills are going to be really helpful, because 2 times 14 is 28, and 2 plus 14 is 16. So we set it up like this. X plus 2, x plus 14 equals 0. Zero product property, and then solve. All right, we're almost there. Remember, find the zeros means set the polynomial equal to 0. All right, once again, are you recognize the pattern? Before you solve, you have to factor. Before you solve, you're going to have to factor these. We want to create a product out of this polynomial. So what numbers multiply to be negative 12? There's, negative 3 times 4. The only problem with that is those add up to be 1. We're looking for 11. There's negative 6 times 2, but those add up to be negative 4. Well, I guess you could try 6 times negative 2, but those add up to only be 4. This is one that people often will not see. What if we did negative 1 times 12? That's negative 12, and when you add those up, you get 11. So none of these work. This one does. Okay, so 0 is equal to x minus 1, x plus 12, 0 product property, and solve. So with all this stuff that I keep doing, if you're seeing the pattern earlier than I am, showing it to you, that's great. You don't have to go through all the possibilities. Once you find out what it is, just go with it. All right, 10 and 11. So notice that with 10, we don't have equal 0. That's a significant issue. So let's go ahead and subtract 7. If we do that, we get n parentheses n plus 6 minus 7 equals 0. Remember, that's our home base, our starting line. We always want to have everything on one side equal 0. Well, those parentheses are a little bit odd too. Let's try to get to some familiar territory. Let's go ahead and distribute this n. We're just trying to make this look like what we know how to do. So if I distribute the n, I get n squared plus 6n minus 7 equals 0. Oh, this feels a lot more familiar, right? We've got ax squared plus bx plus c equals 0. This is what we've been working on for the last 20 minutes. Okay, so now we just need to solve. Before we solve, we have to factor because we want to create a product out of this polynomial. So there's not very many numbers that multiply to be negative 7. There's negative 7 times 1, and there's negative 1 times 7. That's it. So which of those two works? It's this one, because negative 1 plus 7 is 6. So you'd rewrite the polynomial as n minus 1 times n plus 7 equals 0. 0 product property, and solve. Those are your two answers. So I don't know, maybe number 11 is something you can handle. Again, always feel free to pause the video, try, replay the video, and check. Okay, once again, we're in really unfamiliar territory because we don't have equals 0 here for number 11. So I'm going to go ahead and subtract 4 from both sides. It's x squared minus 3 parentheses x plus 2 minus 4 equals 0. And again, kind of like the previous one, this is not familiar looking at all. The parentheses, right? So let's go ahead and distribute across the parentheses, see what this looks like. X squared minus 3x minus 6 minus 4 equals 0. Man, if we just combine our like terms, we get something that really looks familiar. So every now and then there's going to be a little extra algebra to do to get this into a familiar form. We want to try to get to that starting line, that home base where we're familiar and comfortable. Okay, so for what seems like the 100th time, we're going to have to factor. The reason why is we need the left side to be a product, not a polynomial. So to create this product, we're going to factor. We're going to use the c, which numbers multiply to be negative 10. How about negative 1 times 10? Well, that's true. But negative 1 plus 10 is not negative 3. So maybe that's not going to work at all. Maybe we should go negative 2 times 5. Well, of course, this is really close because negative 2 times 5 is negative 10. But negative 2 plus 5 is 3. All we really need to do now is just switch the plus and the minus. Because negative 2 plus negative 5, or excuse me, 2 plus negative 5 is negative 3. So we rewrite like this. X plus 2, x minus 5 equals 0. 0 product property, and we solve. X equals negative 2, x equals 5. Okay, last one before we hop back up to number 1. Football is thrown with an initial vertical velocity of 15 feet. Important. An initial height of 7.5 feet. Important. Right, the vertical motion model for the football. Remember that H stands for the height at any time. T stands for time. V stands for initial velocity. S stands for starting height. So, if you haven't already tried it, here we go. The vertical motion model would be H equals negative 16t squared plus 15t plus 7.5. I'm not going to do anything more with that for the moment. I just wanted to make sure that you stayed current with how to set those up. All right, let's go all the way back. Hopefully our skills are good enough. All the way back to our pool problem. Boy, the numbers are really huge here. Kind of like what we've been doing. Notice we need to factor this. And so I need to think of which numbers multiply to be negative 3,400. I mean, this is particularly difficult. It might take a little while. Yeah, I'm probably not going to give you a whole bunch of these, if any, with these really large numbers. We need to figure out which numbers multiply to be negative 3,400 and add to be 150. A calculator might be really helpful here. Do some thinking. See where this ends up. I'll just pause the video. Maybe really just think about this for a second, and then play the video again, and we'll see how we finish. So I don't know how you did. I just kind of messed around on my calculator for a little while, trying to figure out which numbers might multiply to be negative 3,400 and add to be positive 150. And here's what I came up with. 170 times negative 20. And those multiply to be negative 3,400. And when you add them, you do get 150. So I don't know how long that took you. I don't know if you got it or not. A little bit of practice, a little bit of calculator certainly makes a difference. So we'd rewrite this as x is equal to x plus 170, x minus 20. Then we use the zero product property and solve. So x is equal to negative 170 and x is equal to positive 20. So one of those two answers makes no sense because we're talking about the width of a patio. Of course, the number that does not make sense is the negative 170. You can't have a negative width. The number that does make perfect sense is 20 because a 20-foot wide patio actually does make sense. So in this case here, we'd use a little bit of common sense applied to our answer and just choose the positive number that does make sense. I hope this video has been successful for you. It is an important one. We'll keep factoring. We'll be doing a lot of factoring here in the coming days, and I hope that this video has helped you have some success. See you next class.